Passport to Advanced Math, Lesson 2 is all about simplifying algebraic expressions, dealing a lot with radicals and exponents. Okay, couple of things here. First, whenever we take the square root of a variable expression, so we already know like what the square root of like 16 is, right? What to the second power would give me 16? 4. So you should have all those square roots, memorized. But when we get to variable expressions, such as the square root of like x to the 6th, right? Anytime we take the square root of a variable expression, one thing I would do is just take the exponent and divide it by the index, right? And your index is right here. So if I take the square root, if I don't see a number here, the index is 2. So the square root of x to the third would be, right, 6 divided by 2, which is 3. So that would just give you x to the third. So this becomes the exponent on the outside. But what happens if I have an odd number that doesn't divide by 2, such as the square root of x to the, say, 9th? When I divide 9 by the index 2, right, 2 goes into 9 4 times, and I have a remainder of 1. So what happens is this becomes the exponent on the outside. This becomes the exponent on the inside. So that would be x to the 4th times the square root of x. So right away when I look at this first problem, the square root of 9x squared, the square root of 9x squared. So the square root of 9 is 3, square root of x squared is x. Done. Letter A. That is like a tier 1 problem that we must get. Now, example 2, when I go to look at example 2, what is the square root of 16? 4. What is the square root of a to the 4th? Well, that's just going to be a squared. Now, the square root of b to the 5th. If I take 5 and divide it by 2, I'm going to get 2 goes into 5 2 times, and I get a remainder of 1. So it's going to be b squared on the outside and the square root of b on the inside. So I have a b on the outside, then I'm going to have a b on the inside. Oh, sorry, b squared on the outside. Okay, now c, the square root of c to the 3rd. Well, 3 divided by 2 is 1, remainder 1. So c on the outside, 1c on the inside. And then the square root of d squared is just going to be d. So what answer does this give us? Letter A. And right away, just by knowing the square root of 16, guys, you should know you can eliminate b and c right away, right? And then it's just narrowing it down to a 1 in 2 chance. So next one, rational exponents. One couple of things you have to know here, right? One, if I have a to the m over n, so if I have a fractional exponent, I could rewrite this as a radical with the nth root of a to the m. So this becomes your index. This is your exponent on the inside. Now the other thing is I could rewrite specific numbers as something to a certain power, meaning if I see the number 8, I have to know that I could rewrite this as a base of 2 to the 3rd power. And if you rewrite that, right, those are equivalent. So that's something that's going to play a role here in some of these problems. Last is if I have a negative exponent. So say I have, m over n to the negative 2. Anytime you have a negative exponent in the denominator, what we do is bring that up and make it positive in the numerator. If I have a negative exponent in the numerator, I bring it to the denominator to make that exponent positive. Okay, so right away, let's look at some examples here. First one, which of the following is equivalent to 9 to the 3/4? Now, we know we could rewrite this as the 4th root of 9 to the 3rd. But if I look, that is not an option here. That is not an option here. So if you notice here, they rewrote 9 as a base of 3. So what I have to know is 9 is equivalent to 3 squared. So when I see 9 to the 3/4, I'm going to rewrite that as 3 squared, and I'm going to raise that to the 3/4 power. Now when I raise a power to a power, I multiply the exponents. 2 times 3/4. That's going to give me 3 to the 6/4. And what I have to know is that this could be reduced to 3 to the 3/2. Now what that gives me here is the square root of 3 to the 3rd. That's still not an option here, but if I look here, right, that ends up basically being the square root of 27. And if you remember, that could be broken up into the square root of 9 times the square root of 3, which is 3 root 3, letter D. Okay, now these are all no calculator problems, so you have to be able to simplify these radicals by hand. The next one, x to the negative 4/3. Right away, I see that negative exponent, and I want to get rid of it. And I'm going to rewrite that as 1 over x to the positive 4/3. Now, if I rewrite that using radicals, that's 1 over, remember, it's the cube root, because that's my index is 3, of x to the 4th. Now, right away, what I do is a negative exponent does not make it negative. So get rid of a, get rid of b, right? Get rid of d, and then work from here. So now I look at this, and I say, all right, this doesn't match up with any of these, really. I know it's not the 4th root of x to the 3rd, so I'm going to get rid of that. So can this be rewritten as letter C? Well, I should notice by process of elimination, that's the only one left. That makes sense. So how do I look at that? Well, if I take my exponent 4 divided by 3, that gives me 1, remainder 1. So that would be 1x on the outside and the cube root of x on the inside. So letter C is the answer. Now, these type of problems are a little more, how do you say, a little chaotic, but not hard. So when I look at it, whenever I divide same bases with exponents, I basically subtract them. So I'm going to rewrite this as x to the a squared minus b squared. And that's going to equal x to the 16th. So now I have my single base x. So if I look here, what I'm going to do is say, well, in order for these expressions to be equal, the exponents have to be equal. So a squared minus b squared equals 16. Now I look, I have to solve this equation. But they tell me a plus b is equal to 2. If I notice this is a difference of 2 perfect squares. If I take the square root of both of these, I get a plus b times a minus b equals 16. Well, they told me a plus b is 2, so I'm going to replace this with 2 times a minus b equals 16. When I divide both sides by 2, I get a minus b is equal to 8. All right. Next example, right? Right now, these bases are not written as the same. So I have a base of 8 and a base of 2. So they're asking, if 3x minus y equals 12, what is the value of this expression? So what I'm going to do is say, well, 8 can be rewritten as 2 to the 3rd, all to the x, over 2 to the y. Now when I multiply those exponents, I get 2 to the 3x over 2 to the y. Now, same basis, what do I do with the exponents? I'm going to rewrite it as 1 base of 2, and I'm going to subtract the exponents. So now, look here, they told me 3x minus y is equal to 12. So, what do? I replace 3x minus y with its value, so that would be equivalent to 2 to the 12th, which is letter A. Okay, next example. So I see negative exponents here. So it says this expression where x is greater than 1, y is greater than 1 is equivalent to which of the following. This is relevant, but really doesn't have an impact on what you're really trying to do. So what I'm going to do is get rid of the negative exponents right away. X to the negative 2 is going to come down and become x squared. Y to the 1/2 is going to stay up here. X to the 1/3 is going to stay down. Then y to the negative 1 to make that positive is going to go up. Now, when I do 1/2 plus 1, because I'm going to add these exponents to rewrite that as y to the something, then I'm going to add these exponents to get x to the something. So 1/2 plus 1, if I look, my common denominator is going to be 2, multiply by 2, multiply by 2. So I get 1 plus 2, which is going to give me 3/2. So it's y to the 3 over 2. Then 2 plus 1/3 is going to give me, put it over 1, multiply by 3, multiply by 3. It's going to give me 6 plus 1 all over 3, which gives me 7/3. So I'm going to rewrite that as x to the 7/3. Now notice, none of these are written with rational exponents, so I'm going to rewrite this as the square root of y to the 3rd over the cube root of x to the 7th. Well, when I take this exponent and I divide it by the index of 2, I get 1 remainder 1. So I have 1y on the outside, then I have 1y on the inside. Just by knowing that, I can eliminate a right now. And then here, 7 divided by 3 is 2. 3 goes into 7 2 times, and I have a remainder of 1. So it tells me x squared on the outside, then the cube root of x on the inside. So right away, I look for x squared, cube root of x, which is letter D. And the last one here. If a to the b over 4 is equal to 16 for positive integers a and b, positive integers means just positive and negative numbers, right? What is one possible value of b? Well, when I look at this, if a is a positive number, the one thing they want you to see here is what numbers can be raised to some exponent to give you 16. Well, I know 2 to the 4th power is 16. I know 16 to the 1st power is 16. And I know 4 to the 2nd power is 16. Now, when you think about it, right, I could use all of these in this problem. So if I rewrite a as 2, what do I need b over 4 to divide to? I need b over 4 to equal, I need b over 4 to equal 4. So what would b have to be to give me 4? Well, b would have to be 16 because 16 divided by 4 is 4. So that would be one answer choice you can have. Another answer choice I could do is if I say I want a to equal 4. I know 4 squared equals 16. So 4 to the b over 4 equals 16. What would b have to be in order for this exponent to equal 2? If b is 8, 8 divided by 4 gives me 2. So 8 would be an answer that you can bubble in. If I use 16 to the 1st power equals 16, right? I know 16 to the b over 4 must equal 16. Well, what does b over 4 have to equal? I need that to equal 1. Well, what divided by 4 will give me 1 if b is 4? So right away here, you have multiple answers, and there's even more, but I'm going to stop there. So I just want to kind of give you an idea of what we're looking at there.